Good evening, everyone. Welcome to the second program in our Cape Community Water Forum. Our Water Forum is a four-part series, and I'm happy to be with you this evening. My name is Madhavi Venkatesan. I am the Executive Director of Sustainable Practices. Sustainable Practices is a 501c3 nonprofit founded and based on Cape Cod. Our focus is on promoting environmental stewardship. The Cape Community Water Forum is one of our many outreach and educational programs. We also host a virtual film series screening a different documentary film every month. And we also host a radio show on WOMR the first Friday of every month at 9 o'clock. It is also a podcast that you can find on our website. The Cape Community Water Forum is brought to you by Sustainable Practices, the Association to Preserve Cape Cod, Sierra Club Cape Cod, 350 Cape Cod, and the Blue Institute Labs. It is my pleasure to introduce you to Dan Pelletier this evening. Dan is the wastewater superintendent for the town of Harwich, where he has served since 2016. He's been in the water industry for over 13 years and started his career as a construction superintendent working on municipal water and wastewater infrastructure projects before entering the public sector as a treatment facilities manager. As a superintendent, Dan is responsible for the management and oversight of the public water system, which provides potable drinking water to over 13,000 year-round residents and an estimated 40,000 in the rise in population during the summertime. The Harwich Water Department is a regular recipient of the Mass DEP's annual Public Water System Awards in the Beyond Compliance category and has received official citations from the Governor of Massachusetts, the House of Representatives, and the Senate. Dan is a licensed drinking water operator, Massachusetts Certified Public Purchasing Officer, or official, excuse me, licensed construction supervisor, and holds a BS in civil engineering from Wentworth. With that, I'm very pleased to recognize him this evening and so thankful that he's here to talk to us and share a lot of information that we've all wondered at one point or another. And hopefully through this discussion that we have with him this evening, we can all leave a little bit more enlightened and hopefully enlighten people that we know as well. There is a lot of misunderstanding these days with regard to water, especially our municipal water. And I think it's very important that we highlight this. One thing that I'd like to make sure that you all are aware of is on your Zoom links, you have an opportunity to ask a question. Please look for the Q&A tab at the bottom of your screen. And during the presentation, please feel free to write a question there. We will be taking question and answer after Dan's presentation. And also, finally, after tonight's presentation, you will receive a link to a survey. We'd greatly appreciate your feedback. It really helps us with our programming. And also, it's very nice to hear where we've succeeded and where we can improve. So we greatly appreciate that. With that, please let me again welcome you, Dan, and thank you so much for joining us.
Yeah, thank you for having me. I couldn't think of a better way to spend my night with a group of like-minded people. So my hope tonight is to provide a greater insight into municipal water quality, testing, and the state and federal regulations that govern public water suppliers. With respect to water quality, the United States is regarded as having some of the best in the world, with over 90% of Americans receiving tap water from community water suppliers. If you break that down to a state-by-state comparison, you'll find Massachusetts water quality at the top of the rankings. Massachusetts contains over 1,600 public water suppliers, drawing water from over 3,900 different sources statewide to keep our taps running. That said, water quality does vary from one place to the next, and variations in water quality can even be observed in sources very close to each other. So to produce the quality of drinking water required to meet state and federal regulations, raw or source water is often treated to remove impurities and disinfected prior to entering the public water system. For information on your specific water systems, you always want to reach out to your local water department and get a copy of your consumer confidence report, because that's going to give you exactly what's coming out of your tap. So how is public drinking water regulated? So public drinking water is regulated both at the state and federal level. It's governed through the EPA, through the Safe Drinking Water Act, which was a piece of legislation passed by Congress in 1974. The Safe Drinking Water Act authorizes the US EPA to set national health-based standards for drinking water to protect against both naturally occurring and man-made contaminants that may be found in the drinking water. The Safe Drinking Water Act also established a framework for contaminants that may be found in water. a framework for the EPA, states, water systems, and the public to work together to ensure that the standards are met. Within this framework, individual states are allowed to apply for primacy, which gives the state itself the authority to implement the Safe Drinking Water Act within their jurisdiction. And primacy is a very important component of the Safe Drinking Water Act because it gives the states the right to impose more stringent water quality standards than would have been imposed by federal regulation. And this is an action that Massachusetts has elected to take. Since the Safe Drinking Water Act was passed, or first passed in 1974, it was amended 2 times, once in 1986 and once again in 1996, and was also impacted recently by the America's Water Infrastructure Act of 2018. Some of the highlights of the 1986 amendment included requiring the EPA to regulate over 100 contaminants by 1991. It banned the use of lead materials in water systems, expanded the EPA's enforcement power, and called for tighter regulation of drinking water wells. As many people predicted, the Acts of '86 resulted in detection of various contaminants around the country, requiring very expensive infrastructure projects to remediate the water quality. So, to help the communities nationwide fund these projects, the 1996 amendments established the Drinking Water State Revolving Loan Fund. Other amendments in '96 included requiring public water suppliers to issue an annual report to its customers on contaminants found in the drinking water, more commonly referred to as the Consumer Confidence Report. It also implemented the Source Water Assessment Program, oh, my apologies, and established a process for selecting contaminants for regulation based on health risk and occurrence. So, the most recent and far-reaching amendments to the Safe Drinking Water Act since '96 are the America's Water Infrastructure Act of 2018. So the America's Water Infrastructure Act authorized the Drinking Water State Revolving Loan Fund to allow extended loan terms, making infrastructure investments more affordable, requiring additional subsidies for disadvantaged communities to expand source water protection. It also required community water systems serving over 3,300 people to develop or update risk and resiliency assessments, emergency response plans, and funding by these acts enabled different programs to collect and analyze millions of water samples around the country in search of new contaminants, by which regulating presents a meaningful opportunity for health risk reduction. So when we talk about water quality and contaminants, context is very important. The Safe Drinking Water Act defines the term contaminant as meaning any physical, biological, chemical, or radiological substance or matter in water. So by that standard, anything other than H2O is a contaminant. And it should be noted that drinking pure H2O is not good for human consumption. So we don't want to do that. Our body does require the different minerals that are contained within our source water, but the concentration is very important. So the water quality standards in our state and federal regulations are known as maximum contaminant levels, or MCLs. And MCL is the legal threshold limit on the amount of a substance that is allowed in a public water system under the Safe Drinking Water Act. Massachusetts public water suppliers must treat to standards below to the Massachusetts maximum contaminant level. And they also have to be treated or analyzed through a certified laboratory and through an approved analytical method. So Massachusetts has both primacy drinking water, or my apologies. Massachusetts has both primary drinking water regulations and secondary drinking water regulations. Our primary drinking water regulations identify MCLs, treatment techniques, and public health goals for over 90 contaminants found in 6 categories that all water suppliers must meet. The contaminant groups include disinfectants, disinfection byproducts, inorganic chemicals, microorganisms, organic chemicals, and radionuclides. Our secondary drinking water regulations are guidelines for public water systems to manage their drinking water for issues that are not related to health, and those include 16 contaminants. So our secondary contaminants are things that may affect taste, color, or smell, but again, have no adverse health effects. So it's an excellent thing that over 90 contaminants have been regulated and standards have been set to improve the aesthetic qualities of our water. But what about the contaminants of emerging concern? Things like PFAS, herbicides, and the many other things that, without awareness and adequate protection, may find their way into our water supplies. So the EPA follows a multi-step process for establishing drinking water regulations under the Safe Drinking Water Act. The first step is to identify a list of unregulated contaminants, which is then published as the contaminant candidate list. Once the final list is selected, water suppliers around the world, or country, sorry, collect samples for the contaminants on the list. Contaminants are then prioritized using the monitoring data and evaluated based upon health risk, high occurrence, and risk reduction. So the EPA then publishes a preliminary regulatory determination and gains input from public comment, stakeholders, and after consideration, the EPA then publishes a final regulatory determination with the Federal Register. At that point, the EPA begins the rulemaking process to establish the regulations which will begin regulating those contaminants. So for contaminants that are not considered for regulation through this process, for example, if the EPA puts out sampling for an unregulated contaminant and it's found that it doesn't have adverse health effects and it doesn't occur high or frequently out in the groundwater supplies, then they would not promulgate a regulation for that contaminant because it would be an unnecessary one. There are some instances where there may be a detection, but not a severe one or not a high one where they could advise, develop a health advisory, or they can take no action at all. So you may be wondering, how does this all translate to the real world? So with respect to the unregulated contaminant monitoring rule, after the contaminant candidate list has been developed, water suppliers like myself are contacted by DEP or their representatives, and we coordinate through the EPA with their certified labs to receive the sample bottles and collect the required samples for the program. Upon returning the program samples to the laboratory runs the analysis and they publish all the information to the EPA's central data exchange. So that at that point, the public water suppliers then go in, review the results, and approve them to go up to the EPA. At that point, it goes back into the EPA to that review and analysis process. So where they take all the data from the water systems nationwide and they make that regulatory determination. So that's really the big water system EPA interaction with respect to unregulated contaminants. Now there's other programs that are offered through other state and federal agencies like the Department of Agricultural Resources, for example, right now is soliciting input from public water suppliers to participate in a glyphosate study. So these things happen at the EPA level and they also happen through other organizations in the government. Now, when we talk about regulated contaminants, which is a little different than our unregulated ones, it's much more defined. So water quality testing and the associated reporting is the primary means for ensuring the standards are met in the Safe Drinking Water Act. So Mass DEP issues every public water system in the Commonwealth their own unique sampling schedule. So our sampling schedules identify what contaminants will be tested, where the samples will be collected, when and how frequently the samples will be taken, and if the samples to be taken from raw or finished water. So I included a slide here that has an excerpt from the Harwich Water Department sampling schedule. I hope this translates to the people following along on screen. So if you're looking at the screen, you can follow along here. You'll see a blue arrow at the top left. So the blue arrow is the heading inorganic. So that's telling us that we're going to test inorganics for all of the sources listed immediately below it. So moving over to the orange box are indicators for if we are to take the source is supposed to be finished water or source water, if there is a distribution sample, if it's a multiple sample. So in well fields, if we're taking a combined source sample where multiple wells will pump into one water main, we would take a composite sample. It also indicates if the water system has a waiver for any particular contaminant. So waivers are allowed through DEP through a process where you demonstrate that you have a history of low or no detection in a particular contaminant, and you can apply to get a waiver to monitor. So the reason a water system may want to do that is some of the sampling can be very expensive. So if you've done a multitude of sampling and continually get no detection, they can give you a monitoring waiver. And now that doesn't get you off the hook because you still do have to do periodic sampling. But instead of doing it quarterly or once a year, you may be only required to do it once in a 3-year permit cycle. So moving over to the red box here, you can see this is for 2021. So I want to look at in the green box, Q1, we tested inorganics at our well 10 in our facility. So if we go to the next screen here, this is what the inorganic contaminant report looks like that is provided to EDEP from the Barnstable County Health Lab. So what you can see here is that an inorganic water sample isn't testing for one particular thing. You can see that there's actually 13 different contaminants within that battery of tests that we did. I think that's important to note because when we talk about water quality sampling or we look at our consumer confidence reports that our water systems publish, we may see a handful of chemicals and say, oh, that's okay, we've tested for that, but what about this contaminant or what about that contaminant? So the consumer confidence reports only require water systems to report contaminants for which they've observed a detection. So if you look at the report on the screen, I would only be reporting 2 contaminants from this report, the sodium at 13 milligrams per liter and the barium at 0.0016 milligrams per liter. If we were to report the non-detects that we get throughout the course of a year, our consumer confidence report would be a volume, likely an inch thick. So when you are reviewing that report, know that that is in fact the things that were detected, but not necessarily everything that was tested for. Let's see. So what is in your water? As I just mentioned in the last slide, the contaminants detected in your water supply are reported in your local water department's consumer confidence report. So this is the best place for you to find out where your water comes from, how it's treated, and what contaminants have been detected. So with that, Madavi, I would turn it back to you for any questions.
Wonderful. Thank you so much, Dan. I appreciate your comments very much, and I know the audience has too. We have a couple of questions already, and I'm going to ask the rest of you to please go to the Q&A on the bottom of your screen, and please feel free to send in some questions if you have them. I know that many people have had a lot of inquiries specific to municipal water that were brought up at the last forum. So the first one is related to is a fairly unusual question. And I haven't heard it or thought about this one before, but it's related to food waste. So Jeff and Candy are asking, in terms of food waste, how does that being handled? And is there a risk? I'm assuming, especially if it's being landfilled, how does that potentially impact our groundwater?
So food waste. I'm trying to think of what I guess would come from food waste that could impact our groundwater. I think one of the
Oh,
most
Jeff, I think I made a mistake. That's why the question is a little challenging. What they're asking for is the garbage disposal, not the disposal, not the way I'm thinking of garbage being disposed. So I made a mistake there. They're asking the food waste that goes down the drain and how does that affect our drinking water?
Yeah, so I think, well, with the garbage disposal, I think honestly, your bigger concern would, if you're using a garbage disposal on a septic system, would be a concern because you could uh, cause issues with the function, how your septic system is functioning. If you're in a centralized sewer collection system, that would find its way to the treatment facility and be processed in that way. Um, you know, Another thought is there are some things that do find their way down the drain that can impact our water supply, are things like pharmaceuticals. PFAS is another one. That is a contaminant that's used in nonstick pans. It's used in waterproof clothing, things of that nature. So anything that if you're cooking with, washing a pan, a nonstick pan with an SOS pad, right, and that's draining into your sink and out your waste pipe, that's a forever chemical that could find its way into the water supply. So you certainly want to be aware of what you're putting down there, and treat it as if you are dumping it into the aquifer.
Perfect. I have a couple other questions that are related to the same thing, and it's fluoride. Specifically, there's a question related to fluoride and Harwich water. The other question is just related to how can you know if fluoride is added into your municipal water?
Yeah, so Harwich does not fluoridate its water. It has never, as far as I understand. And in my understanding of fluoridation, I believe it came about in the 60s, if I'm correct. And at that time, a lot of there was a big push from the dental industry, and there was a campaign, and decisions were made by localities, and really haven't changed much since then. Um, so Harwich is a community that does not fluoridate. I'm not aware of any of my counterparts in the surrounding school towns that do. My town where I live in Pembroke does add fluoride to the water. It was made back in the day, and it's been a decision that stuck. Um, in my opinion, I don't want to be adding anything to the water that I don't have to. In my opinion, I wouldn't want to call the water department if I have a headache and have them put Tylenol in there. So I'll go to the dentist for my fluoride. But that said, it is determined to be safe at appropriate within the maximum contaminant levels. So, for people who are concerned or want to know if there's fluoride in their water, they can go to their consumer conference report, because if they are adding fluoride, then they are testing for fluoride, and they would be producing those detections within their consumer conference report.
Wonderful. We have another couple of questions on the same thing. So we have a lot of people thinking about the same themes
Yeah,
tonight. This is specific to a comment that you and I shared earlier, which is related to Eversource. And the question is, how is Harwich working with Eversource to eliminate the use of herbicides near wells, near the wells that are used for drinking water sources?
yeah, and this is a great question, and I'm really happy to be able to answer the way I can. So most recently, I believe it was last year, a local group of residents in Harwich, the Sustainable or Food Forest Initiative, in conjunction with Eversource and the Harwich Water Department, and did a large planting installation. Eversource donated thousands of dollars of edible plantings that were installed by the public, residents of Harwich and other volunteers. And as a result, in the vegetative management plan that Eversource put out this year, I was able to confirm with them that they are not going to be applying herbicide in the right of way where those plantings took place. And what's great about that is those plantings were installed just outside our 400-foot zone one of our drinking water well, which is the boundary where Eversource would have normally had to stop at. So this planting actually pushes that boundary back further, keeping herbicides even further away. So I'm happy and thrilled about that project.
Wonderful. I have a few more questions that are similar, so I'm going to throw them around just to change the variety of questions.
Yeah,
This
yeah.
one is to PFAS and asking, how often is PFAS tested in terms of our drinking water? But the other part that I'd like to add on, so I'm adding on to this question, is we hear a lot about PFAS, but how much of this is related to things that we need to be concerned about because it's imminent in terms of its impact on our health, and how much of it is potentially just news that's able to capture people's attention, if you know what I mean. If I can say it
Yeah,
that way.
so to start with the first one, so PFAS sampling, how does it happen? When does it happen? So the first real initial testing of PFAS took place under the Unregulated Contaminant Monitoring Rule program that I was talking about earlier. So when we did that program initially, we tested for 6 perfluorinated compounds, now known under the regulation as the PFAS 6. So at the time we did the initial PFAS sampling, the minimum detection limit, so when you're analyzing for a contaminant, there is a level of accuracy that drops off when there is a too low of a concentration. So when we were doing the initial round of PFAS sampling, the minimum detection limit was, if I'm not mistaken, 10 parts per trillion. So a couple of years later, as the analytical method improved, we were able to go back and resample. So that was a second round of sampling we did. So Harwich did the initial, and we did it again in 2019. It was a voluntary sampling. DEP mailed out a letter to all the unregulated contaminant monitoring rule program participants, requesting and making them aware that the analytical method had improved, the detection standards were better, and recommended people resample. So at that point, we reran the 6 and an additional 6 PFAS samples. So Harwich, we've now tested for 12 of them. That said, my understanding is there is potentially thousands of these chemicals, right? And when we talk about PFAS and we think about the UCMR program, it's important to remember part of the way EPA is determining how to regulate these chemicals is based upon health risk and occurrence. So there could be 4,000 PFAS chemicals. It doesn't mean there's 4,000 of them in the drinking water. We have to identify first what is present, how present is it, and is it harmful at these levels, and that's something that's really important to remember when we talk about PFAS and when we talk about pharmaceuticals and things of that nature. um, so I think that missed a big part. What are we doing now for PFAS? So this past year, PFAS was formally regulated in Massachusetts. They set a Massachusetts maximum contaminant level of 20 parts per trillion, and that's for the sum of all 6 PFAS compounds. So we sampling for 6 individual, and we add the results for all of those, and it has to be below 20 parts per trillion. So effective this month, we're actually going to be starting to do quarterly PFAS sampling. So is my understanding is that all water suppliers in the state are going to be testing for PFAS quarterly from here on out.
In terms of treatment of water for PFAS, is it possible that it can be removed with a carbon filter or some other simple filtration system?
Yeah, that's my understanding. I was talking to an engineering consultant about that, and that was my exact question: is what is the treatment technique for PFAS? And I was led to believe that carbon is the source or is the way to remove that.
I have a few questions now that are going to be very divergent, which makes this a very interesting discussion. So going back to EverSource, the question is, do the chemicals that EverSource and presumably anyone else uses affect our quality of our drinking water?
Yeah, so we did just test for some pesticides and herbicides under the UCMR 5 sampling program. So that was just very recently conducted, and we did not detect any in our water supply. We also, as I mentioned, the Department of Agricultural Resources is currently doing a glyphosate monitoring program to Roundup or weed killer. So I did reply to that with the intention of participating in that. We did do it voluntarily in Harwich. The samples are very expensive to process. If I'm not mistaken, it was hundreds of dollars to just analyze one. Um, so it's good that these state and federal agencies are providing an opportunity with funding to do this. My understanding and what the literature says is that the half-life of these chemicals is such that they break down uh, quicker than would be possible to impact the water supply. Um, and as we gain more monitoring data through these programs, we'll either be able to validate or disprove that.
Are the question related to pipes in terms, and this is another thing we were talking about before. Are there lead pipes on Cape Cod? And is a question of lead the issue or the potential for corrosion controls the primary issue?
Well, you for I can't speak to every water supplier on Cape Cod, right? Because I don't know their inventory, if any of them have ever laid lead lines. I can speak to Harwich. It's obviously what I'm more familiar with. Harwich never implemented full lead water services, right? So prior to when lead was banned in 1986, they did use what we refer to in the business as lead goosenecks. So where you have the water main and you have what's a corporation stop, which is where the water service is tapped in. And then you have your service tubing. What they used to install was called a lead gooseneck, which was like a 1 or 2 foot piece of lead pipe between the water main and the steel service tubing. And they did that so that if there was differential settlement between the water service and the water main, the lead being a more malleable material would allow for that to move without breaking and causing a water main break. So in Harwich, we've identified or removed a considerable amount. Unfortunately, unless we dig them up, every single 10,000 service in town, we don't know exactly the quantity. But one of the things that we do is a really aggressive water service replacement program. So when the DPW goes out to pave their roads, what we do is renew water services, all of the old ones on the entire street at the cost, department pays for this. And we renew from the water main over to the curb, the shutoff valve on the property line. So through that program, which has been under operation for many, many, many years, we've removed, I would say, confidently the majority of the lead goosenecks in our system. Um, but lead goosenecks haven't posed a problem because, like you said, corrosion is also another factor in the conversation. Um, so the Cape water supply, being groundwater, we do have a more corrosive water coming out of the ground. We are at a pH of 5, 5.5. Some of them higher at 6, but it's relatively consistent. The good thing about that is that we're all equipped to treat that water and to neutralize that pH before it goes out into our distribution system. So for a house that might have been built and they used leaded solder in the plumbing in the house, um, that's not being an issue because we have neutralized the pH and made the water non-corrosive so it won't plate out the lead or copper in your plumbing. So you really need, in the case of Flint, right? It was corrosive water and lead service line. So it's really you need the both to get the disaster, if you will.
We have a question related to an emerging contaminant, plastic in our water. And the question is there any testing for micro and nanoplastics in drinking water?
So I am not aware of any current studies or programs to analyze microplastics. I've heard it discussed, I think, more in the context of marine water bodies um, due to the plastic pollution in the ocean and the breaking down through UV light and things of that nature. Um, so I've certainly heard it referred to in that context, but I haven't heard it is in a big discussion way in the drinking water side.
Thank you very much. Is there cyanobacteria in our aquifer?
Cyanobacteria in our aquifer. I don't. I trying to think. We are there's no, we don't have bacteria in our aquifer. No. So it threw me a curveball there. No, so we actually test our raw water as well as our treated water. So we test for raw water and treated water multiple times a month. And we take those samples to the lab to be analyzed for coliform, which is really a bacteria indicator. So if we have that, then we have problems. But no, the water coming out of the aquifer is really of great quality. The biggest things that we have to deal with are iron and manganese, at least in Harwich. There are other communities on the Cape that have other problems and different source water qualities. But at least in Harwich, we are fortunate to have good water quality, and our main concern is iron and manganese.
We have two interesting questions. They're somewhat related, so I'm going to ask them both to you at the same time. One is related to conservation. if in we actually exercise water conservation, will we be reducing the amount of contaminants that we take out of groundwater? Number one. So I guess the question is addressing whether it's a volume issue that we actually raise the surface of contaminants by having a high volume of pumping out of the system. And the other question is, what does flushing involve?
All right, so I'm just trying to think about the first one here. So the can you ask that one more time? Just I want to make sure I get,
I'm going to
get.
read it verbatim. Okay. Thanks for your interesting presentation. Is there any benefit for water conservation in terms of helping to reduce water systems from drawing in contaminants from groundwater? So, in other words, if we in less volume, does that have any impact? Is it a density issue?
Um, so is it a density issue? Um, well, I guess it depends on what you're I guess what contaminant we're referring to, right? But I mean, I think if the question is kind of talking about if we pump less, will the contaminants be allowed to dilute because there'll be more water in the aquifer to dilute it? I guess
I
maybe is another
that's
way to think about it.
that's how I
Um,
interpret it.
so I guess in that context, I would say, in the case of the Monomoy lens, likely not, because the Monomoy lens, the water, believe it or not, that isn't used, I believe it's 60 million gallons a day that leaves the Monomoy lens into the ocean, and the lens is replenished through precipitation, snow, um, and ultimately, if you don't use it, it does succumb to salt water. Um, so given that they're connected, I don't know that we would really lower the amount of contaminant load.
The other question was related to flushing.
Flushing, yeah. So flushing, what does it entail? So um, good thing to ask, and it's a good time to ask it because we are flushing. So flushing is, as you can imagine, we pump millions and millions and millions of gallons of water through our water mains every year. And although we are removing 99.9% of the iron and manganese, when you're talking millions and billions of gallons, that iron and manganese can build up on the inside of the water main, right? And what we're looking to do with flushing is move the water at a high enough velocity, which is referred to as scouring velocity, where it will remove the iron and manganese that has found itself stuck to the inside of the water main. And the most effective way to do that is through a unidirectional flushing program. So what you want to do is really start at the tank and work your way out. You want to work and bring clean water from the tank all the way to the farthest reaches of your system, to remove that sediment. So each water main size has a different scouring velocity. So on some of the bigger water mains, we have to open up 2 or 3 consecutive hydrants to generate enough flow through the water main before those hydrants to remove the iron and manganese from the side of the pipes. So uh, I guess other things that go into it, there's thousands of gate valves throughout the distribution system. So to accommodate the unidirectional flushing that we want to accomplish, we have to isolate certain water mains to make sure the water's flowing in a particular direction. That requires us to go out and open the valves up, vacuum them out. Oftentimes they find themselves filled up with sand or water so that we can gain access to them. Um, and that's really, really the extent of it.
Thank you for that. We have another question related to homeowners, new homeowners, when they come into Cape Cod, when they actually buy their home in Cape Cod, do they get information with regard to water quality and also to how to protect water quality for the general commons?
Yeah, so I again can speak more specifically about Harwich. In Harwich, we do have a welcome packet that we distribute to new customers with information, eh, like what you were talking about. We also have um, direct a lot of people to our website. We put a lot of information up there with respect to water quality, how you can protect, in all sorts of how to properly irrigate, fertilizer recommendations, things like that. So yeah, that is something that we try to communicate with our customers.
Is there any alternative to putting Clorox in a new well to sanitize it?
Um, Yeah, no, well, it's Clorox, or in more, as we refer to it in the industry, sodium hypochlorite, chlorine bleach. That is a very effective water treatment chemical. It is probably the reason half of our participants are able to sit on the call tonight, was because of the advent of water disinfection. So the other ways to do it, if we're referring to private wells, that's one thing. We have specific requirements that we as a public water supplier have to disinfect our well. So if we were to get a bacteria hit on one of our source water wells, we would chlorinate, take the well out of service, we would chlorinate it, pump it back on, we would test it again to make sure that the bacteria hit was gone, and then it would be put back online. We They also use pantonite, which is it's a new chemical. They use that to clean and redevelop wells. So when municipal wells build up with iron and manganese coming in from the groundwater, sometimes we have to clean and redevelop. So we'll bring in a crane and they pull the pump and the motor, and they inject either chlorine or pantonite or there's other muriatic acid they use to also to clean off the wells. So there are a number of different things. If the person's looking for something specific, they can certainly reach out to me, and I'd be happy to help them with their situation.
We have three questions. They're all very different at this point, but they require a little bit more detail. I think that's why they've been asked. One is, what is the process of eliminating contaminants? And is water treated with chemicals? I think you already brought up that we look at chlorine as one. And how are we filtering out the water? I think that's a really important question for many people because they have a question about the potability of water. We have a question back at you too, if I can ask this and ask you to think about it, is do you think of the same thing when you sit in a restaurant and drink water? Do you think of the same thing when you actually buy water off of the supermarket shelf? It's interesting about all the questions that we have when we talk about the water we take from our tap. So I just want to bring that up in conjunction with this. But thank you, Dan.
Yeah, so I guess I'll start with the first one. What is the process of eliminating contaminants? So that process can vary greatly depending on the contaminant you're trying to remove. For Harwich, we're removing iron and manganese. So the process for that is we are introducing, and I want to touch upon the chemicals as well. So we are adding sodium hypochlorite as a disinfectant, also known as bleach, and we're also adding potassium hydroxide, which is caustic, and that's what neutralizes the pH and brings it up to 7.5. So the chlorine acts as two things. It is a disinfectant, but it is also an oxidant, and that is an important thing for the actual removal of iron and manganese. So the way the process works is as the chlorine oxidizes the iron and manganese particles, they have a magnetic charge. And in Harwich, we have direct filtration. So we have large filter vessels that are filled with anthracite coal and with manganese green sand. And those filter media have an opposite magnetic charge as the oxidized iron and manganese particles. So as the water passes through these filter vessels, the flock particles are attracted magnetically to the filter media. And that is how the contaminants are removed in Harwich. For contaminants like VOCs, volatile organic compounds, oftentimes they'll use air strippers. So that's actually a cool process to see in a treatment plant because they actually cascade water into a giant chamber and they're blowing air up into the bottom of the water, and that's actually removing the volatile organic particles through that process. Um, Another method is desalination, reverse osmosis. I can keep going if you want, or
I think we'll take it to where you feel is probably the natural end point that's not too extreme.
yeah. Well, I
Um,
mean, I think desal or reverse osmosis is a good one to mention, right? Because it is the one process that can really remove everything. It can turn your salt water into drinking water. It in California, if I'm not mistaken, is turning wastewater effluent back into drinking water. that process, albeit fantastic and amazing, is also incredibly costly to operate. So that's one of the good with the bad, if you will. And when we talk about some of these contaminants of emerging concern, and things like pharmaceuticals, and who knows what we're going to start regulating in 10, 15, 20 years. I mean, we have to start to weigh out the cost benefit, and what are we testing, what are the levels, and what are the uh, health risks is something that we really need to consider.
Thank you, Dan. We have two last questions as we go through this process. And the reason why I say this is it's very interesting to listen to or read the questions that come up. The first one is, should we not regulate the price? Is the price so cheap that we're seeing probably misuse, abuse, and not thought and basically thoughtlessness with regard to the use of municipal water?
Um, yeah, and that's a really highly debated subject. Because while we look at high volume users for of water, right? And it's easy to look down and negatively upon. And yeah, we can say that they're wasting the water. And that they should be charged more. And oftentimes the water rate structures are set up so that they are paying more. So um, in Harwich, the rates are set up. We have 4 tiers, and the reason we do that is so the regular homeowner who's a conservative user, they're paying $1.29 per 1,000 gallons of water. That is incredibly cheap. But if we go without water for 24 hours, we're not gonna make it much further as a human, right? So we can't price people out of, uh, affordable water. Um, so, it's a delicate balance. And when we talk about water use, the irrigation use specifically in Harwich, that makes up about 50% of our revenue stream. Is that high consumption user, and they are paying 3, 4 times what the daily user is. Um, but ultimately, if we want to limit high users, everyone is going to have to pay more. And I think that's something that people either need to get on board with, or um, you know, deal with people irrigating.
I have two common questions that are some fairly similar. One is asking, why is it that different Cape towns have different types of contaminants, even though we pull from the same sole source aquifer? And the other related question is, are there some towns that just don't have good quality drinking water, and which ones are they? We had talked
So
about that one earlier too.
yeah, so the second, I'm gonna do the second one quick because I think that's a quicker one. Does one Cape Town have better water quality than the other? It depends on if we're talking about source water quality or the water quality coming out of your tap. Because as I mentioned, we have to remember that the water quality coming out of your tap, regardless of which Cape Town you're in, has to meet and be below the maximum contaminant levels for all these regulated contaminants. So while I can't speak for all contaminants of emerging concern and things that we don't know yet. But with respect to regulated contaminants and the things that we are as public water suppliers regulated to remove, all water suppliers in the state of Massachusetts are going to be producing that quality of water. And if for some reason they don't, they are required by law to notify the consumer, their populace, that they did not meet a specific requirement. Um, and can you jump back on the
The other
second
one
question?
is,
Yeah.
why is it that different towns have different issues with regard to contaminants?
Yeah, so we all have, us pulling from the Monomoy lens, right, or a sole source aquifer. It's important to understand how exactly groundwater wells work. So I mentioned when I was talking about the Eversource project that we did in Harwich, the Zone 1. So the Zone 1 is a 400-foot radius around a drinking water well that is determined to be the area in which groundwater will be drawn from in the regular production of groundwater, right? So on a normal day in non-drought conditions, it can be expected that the water getting put into the distribution system will be coming from within 400 feet of that well. And that is determined through pumping tests when they develop the wells. So they monitor the groundwater in the cone of depression that a well creates when it is pumping. So those are um, you know, one of two regulated areas of influence on a groundwater well. The second one is referred to as the zone two of a well, which is the area in which a well could, in a severe drought condition, draw water from. So, although we're pulling from the same aquifer, the impact on those individual water sources is isolated to most often that zone one and zone two areas. So that is why we have different water qualities from one place to the next.
I have a question here related to if there is a water filtration system that you would recommend, because this family is in a neighborhood where all the water is well water, and they're sharing a common well, so they're not on municipal water.
So I think the most important thing for anyone to do that is considering getting a filter, especially in a situation where you're not in a public water supply, is go to if you're in Cape, go to the Barnstable County lab. And if you're concerned about PFAS, then test your water for PFAS. And if you should do a potability test and you should figure out what the existing conditions of your water are and what things you're concerned about, because the filters are very different. And if you a filter that will maybe remove the taste of chlorine might not remove chlorinated byproducts or a different contaminant that you are concerned about. So I would definitely recommend for people who are considering a filter that they get the water tested first and see what they actually need to remove to bring that water quality within drinking water standards.
One last question relates to water storage. Water storage is it done in terms of the municipalities? Do we have storage tanks for water? And if we do we have to worry about there being contaminated or corroding and or leaching any kind of chemicals into the water?
Yeah, so we do have our water stored in steel tanks. We also have one in Harwich that is a pre-stressed concrete tank. The tanks are required to be inspected monthly by our licensed operators. So we do tank inspection reports every month. And then we also do sanitary and security inspections annually, where in those situations, normally a third party vendor will come in and they will climb the tank. They do and inspect all the welds, the paint, the adhesion, to make sure that the finial screen, 100 and something feet up in the at the top of the tank is intact. So we go through that full inspection, and then every 3 years, what we do is a more thorough inspection where we can actually send in a diver or a rover, and we can actually go in and inspect the interior of the tank as well. Another thing that we do is, and we just did it. Harwich has a tank project going on right now. The tank that's right next to Route 6. Um, we're increasing the pipe diameter going into the tank. And before we did that work, we drained the tank. We had a washing company come in and they disinfect and clean the interior of the tank. So we did that before, we had the contractor come in and cut and weld, and we're going to have them repeat that process before we put the tank back online. So I think that got it.
Yes, the answer is yes. Thank you very, very much for all of these answers. We've actually covered almost 25 questions in the last 30 minutes. I have one question for you. This is based on our private conversation before this evening, which had to do with population density and its impact on Cape drinking water. And you made a very strong point, and I'm hoping that you'll let people know, because one aspect that we don't take care of in our towns oftentimes is participating in town government on a routine enough basis to understand what's happening with the planning boards, what's happening with regard to development. And to the extent that we're concerned and all on this call, listening and learning, we should also be thinking that our drinking water is also dependent highly on population density, both in terms of utilization rates as well as contamination. So could you point out maybe a couple of things that people could do on a civic engagement level that could help protect our municipal water source?
Yeah, so I think I'm trying to recall what I said earlier that you like so much. Yeah, well, I think it's important when we talk about development on Cape Cod and the future of what our towns are going to look like. it's really important to consider the availability and how much water we have. I've seen a lot of planning reports and future growth projections that are allocating, flows that we don't have the ability to even generate within the confines of our Water Management Act permit. So it's important that people understand that. And as far as people getting engaged on the local level, it's incredibly important. Oftentimes when something's detected in the water, it could have happened by mistake. It could have happened because of lack of awareness, or because oftentimes, is this going to affect my water supply? Isn't something that's reflexatory in someone's head, right? It's just something that isn't really there unless you're engaged in it. I think one of the things that would help is really just continued engagement and awareness. Talking about it not just in these forums, but in private with our friends. And the more people know about it and are exposed to it, then it may become reflexatory, and it's something that can, permeate and protect the water supply because we only have one. And unless we protect it, it's going to cost a lot more money to clean it. A lot more money.
Well, with that last comment, it ties directly into the whole concept of community, because if we act like a community, then we're going to be thinking about the community assets at the top of mind, as you've noted, and our goal will be to protect them. And hopefully that will be something that we can continue to do both in these forums and, as Dan has noted, in our private conversations with our friends and other people on the Cape. It's time to get involved and treat each other like neighbors and actually be a community. So I really want to thank you so much, Dan, for taking the time. I know you're a very, very busy person, and we
Of
owe
course.
Dan a lot. Dan has been a great friend to sustainable practices without knowing it directly. He has definitely assisted us with Patrick Otten and Bonnie Bridges in Harwich, and we're always going to be forever grateful for you and your inputs there. So with this, we want to say good night. Again, thank you very much, Dan, for your time. And we hope you all learned something from this event, and we hope to see you next week. And we'll be talking about the single source aquifer. Have a great night, everyone.
You too. Thank you.